Hi and welcome to Bytes and Bits. A lot of my videos so far have been to do with the software side of things, and we've done a lot of games programming, but we haven't yet really done much on the electronics side. So let's make a remedy to that today, and let's start having a look at something called an Arduino. And that's one of these little circuit boards. And on here we have a microcontroller, which is basically a little computer, but it has a number of connections then, which allow us to easily plug it into control devices or to monitor devices. So let's start by having a closer look at the board and then what it can actually do for us. Arduinos come in a range of different formats. Each variant offers different features such as more memory, more input-output connections, or simply a smaller physical size. But they all share the same development system and programming language, so once you've learned how to use one, you can use any of them. In this series, I'll be using an Arduino Uno, which is probably the most common variant. You'll also find that Arduinos are made by a range of companies. The Arduino organisation made the project an open hardware design so that anyone could build their own variation of the system while still being compatible with all the same development systems and code. The Arduino Uno uses an ATmega 328P microcontroller for the brains of the system. A microcontroller is basically a whole computer built into a single integrated circuit. It contains programmable memory to store your code and RAM that you can use for your variables and data. It also provides you with 14 digital input-output pins and 6 analog input pins. And these pins allow you to connect your electronic devices up to the main processor. Now, if you're used to using PCs, tablets, or even a Raspberry Pi, you're not going to be impressed by the performance statistics of an Arduino. The Arduino's processor runs at 16 MHz. Yes, that's 0.016 GHz. And memory-wise, you've got a whole 32 kilobytes of memory for your program and 2 kilobytes to store your data and variables. And again, these values are kilobytes, not even megabytes and definitely not gigabytes. So, you might be wondering, how can you get anything to work on such a low-powered system? Well, the Arduinos don't use any complicated operating system such as Windows or Linux. So the code that you write is pretty much the only code it needs. Everything you do with the board is achieved by talking directly to the microprocessor. Any drivers that you need to talk to external devices, you've got to code them yourself, or usually you can download a library of software that somebody else has written and then include that in your software. And all of this means then is that by getting rid of all of the big overheads of code that Windows and Linux and all use, it means you can actually fit an awful lot inside these small devices. For example, if you've got anything like a 3D printer, then it's almost definitely got an Arduino inside it running the whole process. Now, to get started with Arduino projects, you obviously need to buy a board. But you'll also need some electronic parts to connect to it. So if you're just starting out, my best advice is to buy a project kit. And you'll find lots of these on Amazon or eBay. But the one I'm going to be using in this series is from a company called Elegoo. I'll put some links in the description below to Amazon. The kit contains an Arduino Uno and everything you need to connect it to your PC for programming, etc., along with a wide range of devices and bits of electronics, including connecting wires and so on, so you can start plugging everything together. And this will let you explore all the features of the Arduino for a surprisingly low cost of around £35 for the whole thing. Now, if you're not ready to splash out and buy a kit, you can do almost all the projects using a virtual Arduino. If you head over to a website called tinkeredcad.com, you'll find inside there they have a great online Arduino simulator, or at least a great electronic simulator, which you can also plug a virtual Arduino into. And that will let you build up all the circuits that I'll be doing in this series using virtual components. And in fact, a lot of them will be the same components that I'll actually be using from the kit. It even lets you simulate the breadboard, which is the little circuit board which allows you to plug all these components together just using bits of wire, plugging them into holes. So it simulates all those, so you'll in effect be able to follow along with these projects until you're happy that you're getting yourself interested into the Arduino system. So again, although the simulator is great fun and you can do all of the projects with it, I do strongly recommend that you do try and get hold of a kit of parts. There's something special about actually using real world components and plugging them together and playing with voltages and so on, rather than just it being pixels on a screen. Now, if you want, you can actually buy obviously all these bits individually and build up your kit as you go along. But unless you've got a really good electronics shop nearby, then the postage costs of buying all these bits individually then will make this approach much, much more expensive than just buying a kit to begin with. So do bear that in mind. Well, that's a lot of talking about Arduinos, but their main part is when you actually get your hands on them and start building things. So let's get straight into that and make something. As well as the Arduino board and the components, you'll need some software to be able to program. So if you head along to a website, arduino.cc, you'll come to this website. Then simply go on to the software and downloads. And there you'll see you actually have a choice. We can either use their online web editor, which lets you do all of the programming through their website, or as I prefer to use, the actual downloaded IDE. So if you come down here, you'll see there's a range of downloads depending on what computer you're using. But simply download the one for your computer and install that, and then we'll be able to start programming. So once you first start up the Arduino IDE, you'll come to a blank sketch. The programs for Arduinos are called sketches. That's just a convention we use. So this blank sketch then doesn't actually do anything, but it does show that we have two functions that our system uses. So we have a setup function and a loop function. Now, Arduinos are programmed in C++ language. So if you haven't used that before, it's basically the same as any other language. All languages are pretty much the same. But obviously C++ has its own syntax. So whenever we are defining a function, we have to specify what its return type is going to be. And void is a function that doesn't return a value. But again, as we go deeper into the Arduino programming, I'll explain more of these things as we go along. And what we're really going to try and do now is just make sure that our IDE can talk to our Arduino board, and we're just going to simply get a very simple sketch going and make a little light flash on the board. So that's actually been programmed for us already in one of the examples. So if you go to your File menu and Examples and Basics, you'll see there's a little program in there called Blink. And you'll see, if you look at that, there are a lot of other examples which are ready-made for you. And those are really just to get you started and give you an idea of what to do. But if we load in this Blink sketch, let me just move that into position so we can actually see that correctly. So you'll see here, it has a little description at the top. So these are we use this /star to create a comment block in C++, and it's finished off by this */ down here. And you can see it's just giving a bit of information about what's happening. And really what it's saying here is that most Arduinos have an onboard LED, and the Elegoo one that we're using does have as well. And that's attached to digital pin 13. And that will then flash a little LED that's built onto the board. And if we come down here, you'll see how that works. So in our setup function, that's where we initialize everything. So what we're doing here is we're saying pin mode, and that's a command that tells the Arduino whether you want to make one of its connections output voltages or whether it's going to read voltages. So we're going to set up the LED built-in. Okay, so again, that is a constant that's been defined within the Arduino system. So the LED built-in output, we're going to make that into an output. Then we have this loop, and the loop function is called continuously by the Arduino software. So really, once we have finished doing the setup, then this function loop will be called, and as soon as it finishes, the Arduino does a bit of tidying up, and then it comes back and calls it again. So really all that's going to happen in here is we are going to do a digital write. So in other words, we're going to output a voltage, and we're going to output it to the LED built-in pin, and again that's the one that's internally connected to the internal LED, and we're going to set it high, and that will then set it to 5 volts. We're then going to delay for 1000 milliseconds, which is 1 second, and then write a low, so 0 volts, out to that pin. And in effect what that does is when we send out the high voltage, that will turn the LED on. When we set out the low voltage, that will turn the LED off. So what we need to do now is to connect up our Arduino board to our computer, and then we should be able to download or upload this sketch into it and get it to run. So let's plug the Arduino in. So I have here the USB connection then into the computer, and I'm simply plugging that into our Arduino, and we should find that our computer recognizes the Arduino sitting there. Let me just see if I can just twist that around a bit. So what we should have on our Arduino IDE then is if I go to my tools and board, it should have automatically selected that this is an Arduino Uno board. If that hasn't been selected in yours, you need to go through to your Arduino AVR boards and then select Arduino Uno. Where it says port then, you'll see that when we do that, when we plug it in, one of your COM ports, so one of your serial ports, will be connected to the Arduino, and that's the one we want to select. So once we've got that, we should then be able to simply hit this upload button, and that should then send, first of all it compiles the program. So C++ is what's known as a compiled language. So our IDE will turn all of this into instructions that the microprocessor can understand, so machine code instructions, and then it will send it up to the Arduino, and then we should have a working sketch. So let's send that across and see what happens. So it's going through the compilation process at the moment, and once it's finished that, it will start uploading it to the Arduino, and there it starts to upload it, and that's done. And so what we should see now on the Arduino is we have a little onboard LED just sitting there, and that is now blinking on and off 1 second each time. So that just confirms that the Arduino IDE on my computer is now properly connected to my Uno board, and that we can now communicate with it and send it the various instructions required for that program. We'll now try getting it to work with one of the LEDs out of our kit. So again, we're just simply going to modify this sketch just a little bit. So at the moment it's using the built-in LED pin to do the output. So what we're going to do, we're going to change that now. So I'm going to delete that, and I'm going to get it to use digital output 10. So we're going to set digital output 10 to be, or digital pin 10 to be an output, and then we're going to set digital 10 to be high and digital 10 to be low. And if we look at the actual board then, what will happen here is we have our digital outputs or digital pins along here, and we can see that one of them is marked 10. And really what's going to happen is we're now going to be putting out a 5 volts and 0 volt signal on that pin. So we'll need something to actually plug into that. So I'm using my what's called solderless breadboard here. We will need one of the resistors from your pack, and we'll need to use the 330 ohm resistors, or something around about 300 ohms depending on what's in your pack. So I've just taken one of those out of the strip, and I've then plugged it into the breadboard here. And the way this breadboard works is we have an area of connections in here. And when we look at horizontal rows, if you plug legs of devices into one of the holes in this set of 5 in a horizontal row, then they'll connect together. So I've got an LED here, and I've simply plugged it in. So on mine, I've plugged it in so that my longer lead, which is actually the positive end, that goes into row 20, and then the shorter lead, which is also, if you have a look at the body of the LED, there's a little flat edge there, and that flat edge and the shorter leg, they denote that as the cathode, or the negative part of the LED. So I'm plugging the anode into pin 20, into row 20, the cathode, or the negative side, into row 21. So they just slip in there. I've then got my resistor, one leg of it on row 20 and the other leg of it in row 15. It doesn't actually matter where this one is up here, but as long as it's one side is on pin 20, that will connect it to the anode of my LED. Then I simply need 2 of the wires out of my pack. And again, I'm going to make sure I make a connection with the cathode, or the negative leg of this, by plugging it into row 21. So that will make a connection there. That then is going to be my 0-volt return to my Arduino. So if we look over here, we have our Arduino, and we have a pin labeled GND, which stands for ground. So I'm going to plug that into ground. And then the other side of my resistor, so again, I've plugged my resistor onto row 15, so I need to plug the other end of this wire into row 15. And then that will come to digital output 10, which is that pin there. So I now have my circuit connected up. So if I send 5 volts out on this wire, it will go through the resistor, through the LED, and that should light up. So let's have a check and see if that actually works then. So back onto my computer, I've already modified my code. If I now upload that to my Arduino, as it compiles and then goes up, we should now have my LED flashing. Okay, so that's your first sketch all created and your first electronic circuit built. So if you're using the online simulator, you'll first need to log into Tinkercad. And once there, we go to the circuits section and then create a new circuit. And this will bring up the online editor, and we've basically got a building area here, a component box over here, and once we've added in an Arduino, we will be able to go into our code section and type in a program. So let's build up our circuit. So we can come in here and we can search for things. So let's search for an Arduino, and there's our Arduino Uno. So if we simply drag that across onto our build area, we're then going to come back over here and we're going to search for some breadboard. So let's just make sure we type in here. So let's type in some breadboard. So we've got a small bit of breadboard here. So we can drag that across in. And if we need to turn it round, we've got a little icon up here which lets us rotate that. So there we go. And again, we don't need to name the breadboard. And then I can just simply drag that to position. Right, so we were going to build up a circuit then with our LED. So let's come across here and let's search for, the search box in here is a bit temperamental. So let's find an LED. So let's drag an LED over. Okay, and remember we need to connect it between 2 vertical pins. So I'm going to rotate that round. Okay, and if you look at this here, you can see that we then have an anode and a cathode. So we have to make sure that we get those the right way around. So let's just plug that in there. So again, I'm plugging my cathode in the top one and my anode in the bottom one here. So I then want to find a resistor. Alright, so let's just come out of that. So let's drag a resistor across. So again, I want it to go onto my anode. Okay, so I've got my cathode, anode connected to the resistor, and down to here. And then I need to select a resistance for that resistor. So I'm going to set it to ohms and then choose 300 ohms. Okay, so that gets us our little circuit built up. We now need to connect it to our Uno. So what I'm simply going to do, so I'm going to take a line from my ground pin. So I just simply click on there. I'm not dragging, I've just clicked. So I'm going to come up and across and then down to the same row as my cathode. And then I'm going to come from pin number 10 up, over, down, and then on to the other end of my resistor. So I've now got my circuit built up. Okay. All we need to do now is add in some code. And to do that, we go into our code block. The system does let you use a sort of a scratch type block system, but we're going to go into text because that gives us much more control, and just continue with that. So you can see there that it automatically puts in a little blink bit of code. So that's pretty much connected up to the internal LED. So if I want to just use that to see what happens, I can then just click on up here, I can just click on Start Simulation. And we can see then that we have our little internal LED blinking. But we want to, of course, drive output number 10. So if we stop the simulation, we simply want to set pin mode 10 to be output, and then we're going to output our voltages on pin 10. So if I put the code back out of the way, so that should then, if I start the simulation, we should now find that we have our LED working. Okay, so we get exactly the same situation that we had with our real world components, but now we're simulating it on this Tinkercad system. So that's everything set up now for the Arduino. If you've got the physical device, we now know how to plug it in and upload our sketches to it. If you're using the online Tinkercad system, you know how to put together circuits and add the code to them. So we're really ready to now have a look at all the possibilities with the Arduino. If you've got the kit, there are lots of components in there that I'll be working through, such as ultrasonic sensors to measure distances, servo motors, and so on, so we can get things moving. So make sure that you click on the subscribe button down below. Click on the bell icon to make sure you've got your notifications turned on, and that way you won't miss the videos as I publish them. So I look forward to seeing you in the next tutorials, and bye for now. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.